In this video, we're going to look at solving equations using iteration. Sometimes we can solve equations in a very straightforward manner. So for example, now if we had 2x plus 1 is equal to 0, we could solve for x. 2x would be equal to -1 and x would be equal to -1/2. If we had a quadratic equation, for example, x squared minus x minus 12 is equal to 0, we could factor this x minus 4, x plus 3, set that to 0, and our solutions would be x would be equal to 4 or x would be equal to -3. Sometimes we won't be able to do that, so we either won't spot it or we won't have techniques to solve equations. A good example is x is equal to cos x. For this particular equation, we might want to use an iterative process. What I'm going to do is start with a quadratic equation that we can factor and solve. Then what I'm going to do is look at setting up an iterative formula to solve that equation, and instead of doing it by factoring, we're going to do it by using what we call numerical methods. So here goes. What we're going to have is x squared minus x is equal to 0. So this is a nice straightforward quadratic equation. This quadratic will factor, and it will factor in a very straightforward manner. We'll have x as the common factor, x minus 1, and that's equal to 0. So what we'd have here is that x would be equal to 0 or x would be equal to 1, and we've done that. What I'm going to do is pretend that I couldn't solve that equation, and I'm going to use now an iterative formula. So this is what we do. We let f of x, a function of x, be equal to our original, and this is x squared minus x. So what we're looking to do is solve now f of x is equal to 0. At this stage, we simply split the equation up and write x is equal to some new function of x, which we call g of x. Different rearrangements will lead to different solutions or no solutions. So instead of having f of x is equal to 0, I'm going to have x by itself on one side equal to some new function of x, which we can make from our original equation. So what I'm going to do is two different options here. So with now x squared minus x is equal to 0, which we've got just here, I'm simply going to rearrange this. The first one is the obvious one, and we would say now that x is equal to x squared. So all I've done is simply added the x to both sides. So what we have here now is x is equal to g of x, where g of x is x squared. So that's my new function of x. Let's have a look at another way we could do this. Well, at this stage, what we could say now is that x squared is equal to x, and we could take the square root. I'm going to take the positive square root and say that x would be equal to the positive square root of x. So here I've got, again, x is equal to some new function of x, g of x. So let's just look at these two. Let's just highlight these two. When we look at these, we can rearrange. Certainly when these powers get a little higher, we can rearrange these in different ways. Not all of them will lead to roots or the root that you wanted. Generally speaking, in this course, you will be directed to a certain format that they want you to write that in. At this stage, what we do is set up an iterative process. The iterative process uses a sequence. As the sequence approaches a limit, we can use that to find the value of each of our x's for this quadratic equation. It seems really, really strange. But at this stage, what we simply do is say now that the next one in the sequence, x sub n plus 1 or xn plus 1, will be equal to x sub n squared. We will be given a starting value. When we have that starting value, we simply substitute it in here, square the term, and that will give us the latest iteration of our solution. We will then take that number goes back in, it will give us a new approximation. We will take that number, it will go back in, that gives us a new approximation. And as that sequence continues, feeding the number back in, it will tend to a limit, which will give us now the solution of the equation. So with this one here, the iterative formula or iterative process we would be told to use is the next one, x sub n plus 1. So this is just a sequence. It's saying the next one in the term is going to be now the positive square root, and we'll take the positive square root of the first one. So what we'll do is look at putting these in action. So let's start with this one. Now what we're hoping is that these two different formulae are going to tend to my roots. And what we want to see is one going to 0 and one going to 1. So let's start with this one. We will be given a starting value, and that starting value is x sub 0 or x0. So let's just take now x0 to be 1/2. What I simply do here on a calculator is set this up. I type in 0.5, or if you like, 1/2. What I now do is put in here this iterative formula, and we simply take now where we see an x, we put the answer. We then square this term. What this is going to do is give me now a value to the next iteration in the process of solving the equation. So when I go ahead and press equals, we can say now that x1, our first approximation after the initial one, is going to be 1/4. So 1/4 is now on the left hand side. What we're now going to do is feed 1/4 back in and square that. So all we have to do is hit equals again, because it's going to take this answer and square it. That's going to give me 1/16. So x2 is going to give me 1/16. So this is a better approximation to the solution. What we're now going to do is feed that back in. So on the calculator, you're just hitting equals. It kind of feels a bit like you're playing a computer game from the 1980s. There seems to be very little skill involved. It's just hitting that equals button. So this is now x3 or x sub 3, and that's 1/256. So as you can see, this is decreasing and decreasing and decreasing. What we're hoping for here is that this is going to essentially go to 0. It will tend to 0, and that will be the solution to the equation using that method. So what I'll do, if I do this again, we can see now getting very small, getting very small. And each time I'm pressing this, I'm finding a new value for the left-hand side, which we feed into the right-hand side. So we're getting a new approximation to the root, and it will home in on that root. When you look at these graphically, we have something called staircases and cobwebs. That's beyond the scope of the course, but in a moment I'll show you how this is working to do that. So what we end up with is something like so. So I've as you can see, I've pressed this a few more times, but this is getting very small, and it's tending now to 0. So what we could say then is that the solution, we'll see, and solution is going to be equal to 0. Because that's what it's done. It's kept feeding that number in and squaring it and squaring it and squaring it, and we've come down there. Now graphically, if you wanted to look at this, let's get a different colour. What we've done is now gone ahead and fed values in. So what I've done is set up two equations. I've set up now x squared. So this looks like x squared, and then I've set up y is equal to x. So when we've got x is equal to x squared, if you looked at the two graphs, that's what we end up with. What's happened here is the following. We've taken a value, we started with 0, so we went up, we found out what 0 did. We then put that into x, and then we chose that value to go back into the function, which come here, and then we put that value in, and we chose that to become a function. So what you can see inside these two, we've got now this spiraling staircase, and it will locate the root, because all it's doing is subbing in a number, then it's taking that to be x, then that goes into x squared, and if we look at this in a more pure form rather than me putting the values on, what you'll end up with is something that looks like this. So let's go ahead and put this on. So let's say that was 1/2. We do this, it comes down, we do that, it comes down, we do that, it comes down. So each time I'm pressing equals, it's choosing a new one, and it's going to locate this root right here. So let's go with this one right now. So let's start on this one with x is equal to, and we'll put this on. So that's located one root, and we know that one of the roots was 0, which worked out quite nicely. So let's look at this one right here. Let's start with our first one of x naught or x sub naught. The reason we say sub is because that number's a subscript. That small naught is sub at the bottom. X naught, let's go for 0.6. So all I'm going to do is the following. You take your calculator, you put this 0.6 in. So 0.6, you hit now equals. All we do is simply put this in to this iterative formula. So the next one will be the square root of the last one. The next one will be the square root of the last one. The next one will be the square root of the last one. And what that's doing, on the left-hand side of the equation, it's giving this value of x here, which becomes slightly better each time. As stated, not all rearrangements of these equations, luckily with the quadratic we don't have an awful lot of choices, but not all will tend to this a root or go to the one we want. But again, certainly that's beyond the scope of the course. They're not going to be that harsh. So all we're doing is simply subbing this in. So we want the square root of the answer. So this now gives me, and if we just write this in, this is the first one. So x1 would be equal now to, so 0. Double blah, blah, blah. Now you may be asked to give these to 3 decimal places. It's really quite reasonable that they should do that. And then of course you could get x2 and then x2. This is now being fed in here to get the next approximation. So here equals 0.88. So that's x2, that's x3, that's x4, that's x5, that's x6. You can see that it's slowly tending to the root that we want, and it's a lovely feeling. Some of these, what we call these converge, they'll converge to the root. Some of them will diverge, and again, the reason they diverge is a bit beyond the scope of this, but some just get very big very quickly, all to do with the gradient of the function at the time. But look at that, it's just, well, you know where it's going. And clearly we wouldn't right now, I think we're up to about x sub 13, x sub 14. You might be asked to write the first 5 or 6 in, you might be asked to write however many, you might be asked to write x1, x2, x3. But as you can see, that is gradually tending to the limit of this sequence. This is just generating the terms, and look at that. The calculator will just default to 1 as it approaches. Let's go there, look at that. There's something quite pretty about that. So that's done it like so. Now, let's say, so we can see there that the limit of that sequence is going to go now to give us our solution of our equation. Right, there were alternatives to this. So if you look at this, we could have taken the negative square root. Let's take the negative square root and see what that does. So what we'll do, we'll start again with 0.6 and press equals. We will now take negative root of the answer. See, straight off, that doesn't provide us with a solution. So you can see on here that not all rearrangements are going to work. So let's say we had, well, let's look at the one we started with. So what did we have? X squared minus x minus 12 is equal to 0. So what we know that the solutions to this are going to be positive 4 and negative 3. We saw that just here. So how could we write this now? So this is f of x. F of x is x squared minus x minus 12, and f of x is equal to 0. So what we might want to do here is write g of x. X is equal to g of x. So let's look at some of the rearrangements we could do. So straight off, what we could say is x would be equal to 12 minus x squared. That would give us 1. So now x is equal to g of x. So if we set up this iterative formula, x sub n plus 1 is equal to 12 minus x sub n squared. What else could we do with this? Well, what we could do is write now that starting off with x squared is equal to x plus 12. So x would be equal to the positive square root of x plus 12. So x is equal to g of x, so our iterative formula. So x sub n plus 1, the next one in the sequence, is going to be now the positive square root of xn plus 12. What else could we have done? Just looking at possible rearrangements, at this stage we could have written that x was equal to x plus 12 all over x. just dividing through by x, that would give us 1, wouldn't it? So x sub n plus 1 would be equal to x sub n plus 12 over x sub n. And of course you could simplify that to 1 plus 12 over x if you wanted. And then all you would do is be given a starting value. You might not be given a starting value. But let's have a go. Let's have a go at one of these. So if we started with 2.5, and let's just put it in this one. So what we'll do then is the answer, so the positive, square root of the positive of the answer plus 12. See what this does. So here, look at that. What's that going to do? It's going to locate my 4, which is lovely. So we use that one. But if we use this one, let's try 2.5 with this one and see what this one does. So this one, you could write this now as the answer plus 12 over the answer. Again, I've started with x naught is equal to 2.5, which is a reasonable starting point. What's this going to do? Right, that one there, you can see now that it's starting to look. Where are we going with this? That isn't horrendous either in terms of what it's doing. It seems to want to tend, look at that. So that one is fine as well. Look at that, there we go. So that one tends to 4. Now if we try 2.5 in this one, what are we going to get? So this is going to be 12 minus now the answer squared. So what's this one going to do? 12 minus the answer squared. So we can see now that this one right here doesn't give us those things. So different ones will lead to the different solutions, and different starting values of x sub n will be taken to locate those roots. So there we go. Let's actually have a look at a question now and see what we've got. So it's the equation x cubed minus 13x plus 12 equals 0 has 2 positive roots and 1 negative root. In part A, we need to show that the solution, the equation x cubed minus 13x plus 12 equals 0 can be written now as x is equal to a cube root of 13x minus 12. Well, that's just x is equal to g of x. So all we need to do is rearrange the equation. Usually when you rearrange an equation, you make something the subject. What's slightly bizarre here is that we're making x equal to something in x, which is less intuitive. So let's start here. What we've got then is x cubed minus 13x plus 12 is equal to 0. So I'm going to write now that x cubed is going to be 13x minus 12, and then taking the cube root of both sides of the equation, we can say now that x is equal to 13x minus 12. So at this stage, what we had is f of x is equal to 0. What we've now got is x is equal to g of x, where g of x is a new function that I've created based on the terms in the original equation. Taking x naught, the first one, or x sub naught, to be equal to 0.4, use the iterative formula x sub n plus 1 is equal to the cube root of 13 lots of x sub n minus 12 to find x1, x2 and x3 to 3 decimal places. So this is nice and straightforward. So if we've got now, so this is just x is equal to g of x. Now we set up the iterative formula and we've got it given to us, nice and straightforward. In this particular course, as far as I can see, we're only going to have quadratic and cubic functions. Certainly when you go beyond this course, you'll have all manner of different functions. So let's do this. So what we've got then is x naught is equal to 0.4. So in the calculator, all we do is type in, so just start fresh, 0.4, you press equals. Then this is going to go into the cube root, so we press the cube root now, of 13 lots of the answer minus 12. So what this is going to do is give me a new x based on the first value of x naught. So that gives me this. Right, so what I'm going to write is x1. So x1 or x sub 1. We need to give this now to 3 decimal places. So what's that going to be? Negative 1.895. Negative 1.895. This is always easier for you to do because my calculator, as soon as I write on here, disappears. So that's to 3 decimal places. Now we need x2. So all I have to do, remember, what this is going to do is take this number in here and give us our next approximation. Negative 3.321. So x2 is equal to negative 3.321. Let's just check that. There we go. And then we'll do the next one, x3. So x3, remember, that is now going in for our answer here. So that is going to be negative, we want this to 3 decimal places, don't we? What's that going to be? 807? Negative 3.807, all given now to 3 decimal places. I'm pretty sure I rounded those correctly. We now need to find the negative root of that equation. Well, all we're going to do is keep going. I'm not going to write down. You might want to. Again, it depends on which course you're doing and the spec that they ask for. I'm not going to, certainly as we saw some of those tend to the root in a very pedestrian manner. It takes a lot of iterations to get there. When we talk about iterations, it's like, for example, if someone produces a manual, there's loads of different iterations. There's loads of different examples of it or versions of it. It's a similar sort of concept. So let's just keep going with this. All you do is hit that, hit that, hit that, hit that, and look at that. Where's this going? That is tending to negative 4. So find the negative root. X is equal to negative 4. So, should we check that works? Well, let's just go ahead and simply now sub this in. So if this works, this should set it now to 0. Hopefully we can see that this is going to work. Minus 13 lots of negative 4. So negative 4, and then we're going to add to this 12, and that will give me now 0. So that is a root of that equation. We could look to find the others. We're not asked to, we're just told to, as stated earlier, these are very well guided. We could have rearranged this in a different way. What we could have said now is that x cubed is going to be equal to, so x cubed plus, let's do a different one. So x cubed, let's go on here, x cubed plus 12 is equal to 13x. So we can say now that x will be equal to x cubed plus 12 over 13. So the iterative process, or iterative formula, would give us x sub n cubed plus 12 over 13. So if we looked at this one, for example, let's go ahead on that. Let's choose, let's put in here 1.5. Let's start with x naught 1.5. So setting this up, what I'd have is my answer cubed plus 12 all over 13. So let's go ahead and do that and see what this does. So I've substituted that in, and let's see where we go with this. There we go. That looks like it's tending to 1. Is 1 a solution to that equation? Well, 1 cubed minus 13 lots of 1 plus 12 is, that's 1 minus 13, that is the solution. So there we go, that's what we end up with. But as stated, on certain equations there will be rearrangements that don't lead to a root. So that is solving an equation using an iterative process. I've not delved into too much in terms of the graphing when it looks at the spirals or the staircases and the cobwebs. There is a video on that on another particular unit, but hopefully this has given you a good starting point to solving those equations.